Hi, this is Ms. Nickel, and this video is about how to draw electron dot diagrams and how to use them to figure out how many covalent bonds an element will form. So first we're going to review the periodic table, and there are three categories of elements on the periodic table. We have the metals, shown in white here, which make up about 3/4 of the elements. So I'm just going to write that to make it clear. Metals are white on this periodic table, and metalloids, starting with boron here and going diagonally down along this dark line we call the staircase, they're in dark gray, and they have properties in between metals and nonmetals. They're called the metalloids. So M-E-T, like this, O-I-D-S, and those are shown in dark gray. All right, then the elements that we're most interested in focusing on for our upcoming work, which is going to be figuring out how many covalent bonds an element forms and drawing Lewis structures. So the elements we're most interested in are the nonmetals up here in the right-hand corner, and that includes carbon, nitrogen, and oxygen, other elements that form living things, halogens in tall group column 7, which are toxic gases, and our noble gases, which do not react chemically. They're in tall group column 8. I'm going to draw a green marker line around the nonmetal elements, and I'm going to include any metalloids that are on the right side of the staircase, because we will be using these in Lewis structures, and I just want you to not be confused when we do that, and we're just going to treat them like covalent, like nonmetals, which will make covalent bonds. Now we're also including the noble gases here with column number 8, which has helium at the top, but they are not chemically reactive. The only nonmetal that is not on this side of the periodic table is hydrogen, which is over here in the left-hand corner, but it's a very important nonmetal element, and it does form covalent bonds. So a couple things we want to make notes of then. One is that nonmetals on this periodic table are outlined in green right now. Okay, so I'll say nonmetals equal green. And that our nonmetals are the elements that participate in covalent bonding, which means nonmetals form covalent bonds with other nonmetals. And I'll write this at the top. Okay, metals do not do this. So nonmetals form covalent bonds with other nonmetals. So now that we know that nonmetals make covalent bonds, we need to learn a bit more about valence electrons, because we're going to be using valence electrons when we draw our electron dot diagrams and move on to Lewis structures. So valence electrons are just the electrons in the outer energy level or outer shell of an atom. Okay, so electrons in the outer energy shell. And this is an oxygen atom right here. I know that because it has 8 protons. And right now, it has 8 total electrons. Now, the valence electrons are only these 6 electrons here in the outer shell of this oxygen atom. I'm just going to label that as oxygen. Okay, so valence electrons and total electrons are different. Why do we care so much about the valence electrons? Because they are going to determine the chemical properties of the element. Okay, and once again, oxygen has 6 valence electrons. Now, there are some rules about valence electrons that we need to be familiar with, and they determine whether an element bonds and how many bonds it makes. The first is the octet rule, and oct in octet means 8. So the octet rule says that atoms with 8 electrons in the outer shell are very stable, and that atoms will gain, lose, or share electrons in order to get an octet. And so as we go into covalent bonding, we're going to be talking about sharing electrons, because that's what covalent bonding is. It's when atoms share electrons to get an octet. So this is our oxygen atom again, with its 6 valence electrons. Okay. I'm just going to put an E for electron, E minus, because they're negative. And then we have an atom of neon here, which is in the same row as oxygen, but it's a noble gas. And so it's the same number of shells, but it has 8 electrons in its outer shell. And so it is stable, meaning that it doesn't make bonds, and oxygen does. Okay, so it has 8 valence electrons. That's the octet rule. Now, almost all the elements follow that. The only exception are hydrogen and helium up here at the top of the periodic table, here and here. And because they're in the very top row of the periodic table, which only has 2 spots, they have a small energy shell, which only holds 2 electrons, and they follow the duet rule, which means 2. Okay, so hydrogen and helium are the only atoms that follow this rule, and they have only 1 energy shell, and it only needs 2 electrons. So helium, shown here, already has 2 electrons. And it is stable, meaning that it won't form any bonds. Okay, so 2 valence E, whereas hydrogen, shown here, does a lot of covalent bonding, and it only has that 1 valence electron, so it's always wanting to pick up another electron. And it's going to do that by sharing electrons with other atoms. Okay, so now we're going to talk about how do we figure out, what's an easy way to figure out how many valence electrons an atom has, because we're going to need to know that in order to predict how many chemical bonds an atom will form. Okay, so of course we're going to go back to our periodic table, and we're going to do a little different numbering system here. We're just going to number these tall group columns. I'm not going to go into all the details. We figured this out before in class why this works, but right now we're just putting numbers at the top here of the tall group columns. So I start out with column 1. Columns go up and down. They're also groups, and I put a 1, then 2 here above column 2. We're going to skip our transition metals in the center. They're not forming covalent bonds. And we skip them for ionic also for another reason. And then we're going to come over here and number these columns: 3, 4, 5, 6, and 7. The noble gases would be 8, but we're not going to number them because we won't be using them in this kind of bonding. Well, I'll go ahead and put an 8 there because we might just do it when we do the electron dot diagram. All right, so the rule you need to remember then is just that the valence electrons are going to be equal to the tall group column number. And I'm going to show you an example of this first with nitrogen, and then we'll go back over our rules. Okay, so nitrogen is right here. It's in tall group column number 5. So when I do an electron dot diagram, I draw the element symbol. That's my first step. And then I'm going to give it the same number of valence electrons as the tall group column number, and I'm going to represent those with dots. So I'll start on any one side of the atom. I usually start on the top, and I put 1 dot on each side. We've got 5 dots for nitrogen until each side has a dot. And then I start to double up. So with nitrogen, I get to number 5, and I have no more valence electrons because nitrogen has 5 valence electrons. So that's my basic electron dot diagram. So we're going to write down our first rule. Rule 1 in this case is going to be electron dots are the same as tall group column number. Keeping in mind that our electron dots are our valence electrons. Okay, and then our rule 2 is going to require us to understand the difference between single electrons and electron pairs. So any electron, when we have only one electron on the side of an atom, is going to be a single electron. Just a matter of terminology, but it's important to understand what we're talking about there. So single electron means only one electron on that side. The other situation is when we have a pair of electrons, which is shown here at the top of nitrogen, right? And so these electrons will not form bonds. This is a pair of electrons. Okay, so our next rule is going to talk about that because it says that single electrons will form bonds, will form covalent bonds. Okay, so now we are going to take a look at the other elements that I have listed here, keeping those rules in mind. I'm just going to fold this over those so that we can look at our periodic table. And we're just going to fill in the information in this table. All right, so we have got a series of elements that we're going to draw electron dot diagrams for. For these, we just look at the tall group column number, 1 for hydrogen. So it gets a single dot. It doesn't matter which side I put it on. Beryllium gets 2 dots. Again, doesn't matter which side I put those on as long as they're singles. Boron is going to get 3. Carbon, 4. Nitrogen is our element that ends up with 5. And here I'm just going to draw it a little bit differently just to show you that it really doesn't matter. I've got a pair here and 3 singles. I can put them in any side as long as I do only pair after I have 4 or 1 on each side. For oxygen then, I've got 1, 2, 3, 4, 5, and 6. So we have 2 pairs and 2 singles. Fluorine, I've got 1, 2, 3, 4, 5, 6, 7. Just to show you here, fluorine's in the 7th column. Making sure you guys can still see that. Yep. And then neon is going to have 8. So I could just draw pairs on all those sides, but I follow the same system. And I go around once, and then again, I end up with pairs on all sides. To decide if they're metal or non-metal, we just look at where they are in the periodic table. Hydrogen's in the green, so that's going to be a non-metal. Beryllium is in white, so we have a metal. Then boron is actually a metalloid, but we're going to call it a non-metal for now, and all the other elements that I have here are the same. So these are all nons. And will it form covalent bonds? Well, nonmetals form covalent bonds with other nonmetals. Metals cannot form covalent bonds. So our metal is going to be our only no, and the rest of these are going to be a Y for yes. Okay, and then how many bonds will it form? This is really probably the most important thing that we're doing for this video. So the number of bonds, we're going to follow that rule that we had before, and the rule said that single electrons will form covalent bonds. And so the other part of this is then number of bonds will be equal to number of single electrons. Number bonds equal to number single electrons. So if we go back here then, we can just count the single electrons. 1 on hydrogen, 2, I almost made a mistake there. Will it form covalent bonds? No. So beryllium, because it's a metal, it doesn't form covalent bonds, even though it has 2 single electrons. Boron, we're treating it as a nonmetal, so it's going to form 3 carbon, 4 single electrons. Now with nitrogen, we start to go down again because now we have 1 set of paired electrons and 3 singles. So we're going to say 3, and then we'll say 2 for oxygen because it has 2 singles. Fluorine only has 1 single, and neon has 0. Okay, so there you have it. That is how you draw electron dot diagrams and figure out the number of covalent bonds an element will form. I will have another video for you to learn about how to use this information to create Lewis structures.